Hello, dear students, welcome back. So, I hope I am audible and visible to all of you. Clear? Hello, dear students, welcome back. Yes, so I can get my voice, so I am audible to you now. So, let us start. One second. Okay. One second, one second. Okay, now. Okay. I guess this screen is visible to you now. I guess this screen is very visible to you. Yes. Let me check. Okay. Now, let us start lecture number third of AC. We will start the class by doing a simple numerical. And the numerical is like the C. Capacitance is given as 40 microfarad. Done. And this capacitor is connected. This capacitor is connected to 220 volt source with 50 hertz frequency, and the source is AC supply. Find current's RMS value. Sir, what is RMS value? How to find it? We know that V equals to IR. We know it now. V equals to IR. If V is RMS, I is RMS. So what is V? I guess V is 220. I, we don't know. What is R? In C, R is XC. Capacitive reactance. So I can write 220 equals to I. XC is 1 by omega C. So I came out to be, it will be 220 multiplied by omega multiplied by C. I 220, what is omega? It is 2 pi f into C. I 220 into 2 into 3.14, frequency is 50, then C is 40 10 to power minus 6. So look, it is 4 1 0 2 0 3 0. I can write here plus 3. It is 44 multiplied by 3.14 into 5 4 20 10 to power minus 3. 1 cancel out, plus 1. It is 88 multiplied by 3.14 10 to power minus 2. 8 3s are 20. I guess my answer came out to be 2 point something, 2.5 10 to power. No, 2.5 only. Now it gets cancelled out now. 2.5 ampere. 2.5 ampere is my answer. Easy and simple one. Okay. By doing this numerical, we recalled some topics from the previous topics also. Let us do one more numerical. And numericals, it is not basically numerical, na? It is basically a manipulation of our equations. How, sir? Look, if if we are dealing with pure C, pure C, pure C means in which my current leads, my current leads, my current leads. So first equation, let's suppose we are having two numericals from this particular topic. First one is if V is given as V naught sine omega t. Second one is I equals to I naught sine omega t. Now we have to write it is I equation. Look, I equals to, it will be I naught sine omega t plus pi by 2. Why pi by 2? Because it is leading now. It is leading now here. Okay, done. I can write it as I equals to I naught. We know that V equals to IR. So I is V by R. I can write V naught by R. What is R? R is XC. Then sine omega t plus pi by 2. One more equation. Or I can write it as a V naught divided by 1 divided by omega C. Then it is sine omega t plus pi by 2. Now here V. What is V now? V will be V naught sine omega t minus pi by 2. Done. Or I can write V equals to V naught. What is V naught? It is I naught XC sine omega t minus pi by 2. This thing now. So the purpose of showing these two equations is like, if my current equation is given in any R, C or L, we can write the V equation. If V equation is given, I can get my I equation. One more thing. Look now about frequency. About frequency. First, if we are talking about R only, if in a circuit R is given, no effect of frequency. Second, if we are talking about capacitor C only, clear? So what is XC? Is it 1 divided by omega C, right? I can write 1 divided by 2 pi f into C. So therefore, my resistance XC is inversely proportional to my frequency. If frequency more, resistance is low. Okay, so at very high value of f, if we are having a something like this now, we can just change it to a short circuit things. Why? Because minimum opposition now, it will give us minimum opposition. Third one, if we are having inductor only, what is XL? Equals to omega times L, or 2 pi f times L. So if my f is more, my what? My XL will be more. So opposition will be maximum. Okay. So I can write, or I can make it like as a open circuit. So now if I need to make a graph of it, frequency, R is independent, so this is my R. Done. Look here, omega, this accuracy and frequency, is it hyperbola now? I can make it a rectangular hyperbola. Third one, it is directly proportional. I can make it as a directly proportional. Okay, so this one would be how much? This one is for C only. This one is for I only. This one is for I only. Done. Now give me 1 minute. I need to get some numericals for you. For that thing, I need your couple of minutes. I hope that you can give me those minutes, right? 1 second. Okay. Okay, now I got it now. 1 second, beta. One. In this class, we will do a lot of numerical practices. Second numerical. Third. Fourth. So I have given you Srinidhi. Wait, beta. Wait. Okay, now. Okay. Numerical on your screen. This numerical. I hope this numerical is visible to you. It gets big. Okay, now I hope this thing is visible to you now. Okay. So what is given to us? So you can see now a coil of inductance this much. So inductance is given to us, that is L. L is equals to 0.1 Henry. It is connected to an AC generator of voltage. So this is voltage equation. Okay. Now we have to find out current. We need to find out current. Okay. Look now. What is equation of current? So current is I equals to I naught sine omega t. It is a L circuit. In L circuit, my current lags. Na? It is pi by 2. In my L circuit, inductor circuit, my current lags. Okay, now look now. So we don't have the value of I naught. How to get it? No? How to get it now? What is V? V equals to IR. V equals to IR. I know it. Okay. So I will write V naught, I naught, I. Let us suppose it. Okay. What is V? I guess this is my V naught. Yes, sir. It is 100. 100. I naught. I don't get it. What is I naught? Let it be as it is. So it will be now X times L. Okay. I can write 100. I naught. What is XL? Is it omega times L? Yes, sir. So now compare this equation as E equals to E naught sine omega t plus phi. So now omega came out to be 100. So I can write 100 equals to I naught, then 100 multiplied by 0.1. 100 cancel out. So my I naught came out to be 1 divided by 0.1, which is equals to how much? it is equals to 10 now. It is 10 now. Look, I can write I equals to 10 sine omega. What is omega? Omega is 100t minus pi by 2. Is there any option about this one? 100t minus no. So look now. So I can also write it as we know that sine omega t minus phi is it equals to minus cos omega t. So I will write this equation as I equals to minus I naught cos it is 100t. Done. So I guess no, wrong, wrong, wrong. Option number D. Option number D is correct. Option number D. Option number D is correct. Okay. Option number D. A good numerical. Can get it now. Okay. Next numerical now. Next numerical on the screen now. This one is done. This one numerical now. Okay. So numerical is like an inductive reactance of a coil is 1000 ohm. That simply indicates 1000 ohm. That means that inductive reactance. Inductive reactance means XL is it equals to 1000 ohm. Okay. If it is self-inductance and frequency both are increased 2 times. Self-inductance means if L go to twice L and F goes to 2 times F, then inductive reactance will be. Okay. So what is inductance? What is inductive reactance? That is XL. Is it omega times L? Okay, or XL equals to, is it 2 pi F into L? So omega L is proportional to the F and L. So I can write omega L1 divided by omega L2 equals to F1 divided by F2 multiplied by L1 divided by L2. Omega L1 is 1000. I will write here 1000 divided by XL2. Frequency is F. It is 2 times F multiplied by L, 2 times L. Cancel out. It is 2 to the 4. So XL2 came out to be 4000 ohm. 4000 ohm. Option number C. Option number C is correct now. Okay. Easy. You can take a screenshot now. Now next numerical. This numerical now. It states that an alternating voltage E equals to 200 root 2 sine. So I can write it as a E equals to E naught sine omega t. Okay. So by this equation, my E naught came out to be 200 root 2 and my omega came out to be it is 100. Okay. And my capacitance is given as 1 10 to power minus 6 farad. Done. Reading of ammeter. If we are talking about AC and AC, if ammeter is there, so ammeter reads only RMS value. You know it now from previous class. Okay. So if RMS is given, so what we need to find out? Current. That is IRMS. We have to find out IRMS. So IRMS is equals to VRMS divided by X times C. Okay. What is VRMS? Okay. So look now how to find out. So V naught is given as 200 root 2, which is equals to. So do you know what is the equation for RMS value? No. So VRMS equals to V naught by root 2. I will divide this thing by root 2. Root 2, it will become now VRMS. So my VRMS came out to be 200. 200. So I will write here 200. What is XC now? XC means, is it 1 by omega C? Okay, I will write here omega C. 200. Omega is how much? 100. It is 100. And C is 10 to power minus 6. Look, 2 to 4. I will write 2 10 to power minus 4. So is it 20 10 to power minus 3? That means 20 milliampere. So 20 milliampere is my answer. Option number 2. Option number 2, 20 milliampere is my answer. Okay, now next one. Now I have a lot of numericals, right? Lot of numericals. This one now. Okay, look now. This numerical like, and if an alternating current, this is my alternating current equation, is flowing through a capacitor. So capacitor is given. So in capacitor, my current leads. Then voltage drop delta VC across capacitor is. Okay. So if we are talking about capacitor, for capacitor, my current leads by pi by 2. We know it. So if you need to make a V, so V came out to be V naught sine omega t minus pi by 2. We know it. V equals to, what is V naught? What is V naught? Sir, Ohm's law, V equals to IR. IR. Done? So I, what is R? R means XC. I will write here I, XC. XC means omega C. So I will write here, it would be I divided by I naught divided by omega C. So we are having sine omega t minus pi by 2. Sine omega t minus pi by 2 is minus cos omega t. So V came out to be minus I naught omega C. Here will be cos omega t only. I naught or I am no issue. Omega C cos, right? So which one is correct now? No, this is wrong. Wrong. Option second is not correct now. Okay. Next numerical. I guess we are in the speed, no? So my next numerical. Okay, you can see next numerical. Next numerical is in an AC. We are having a AC circuit of pure capacitor. Pure capacitor means current leads. Now my EMF equation is given as like this. If the peak value of current is 200 milliampere, the value of capacitor is okay. So how we can get it? Look now. Pure capacitor means current leads by pi by 2. So E equals to E naught sine 1000 t. Okay. So E naught is given as 100. So I can write E naught is equals to 100 and omega is equals to 1000. Okay. So I will be equals to, is it I naught sine omega t. Omega is 1000 t minus pi, plus pi by 2. So I naught is given to us. Yes. So how to write an equation now? So V equals to IR. So V equals to I times R. Done. So what is V? V is given as 100. Yes, sir. I is 200. 10 to power minus 3. Yes, sir. R will be omega times C. It will be 100, 200, 10 to power minus 3. Omega is 1000 into C. So look, 20 cancel out. So 2130. So what to write now? I guess my C came out to be 2 10 to power minus 6 farad, right? Farad. So C came out to be 2 microfarad. 2 microfarad. Okay. Next numerical. So I am giving you the different types of numericals so that you will have a good grip on it. A very good grip on it. Now this one numerical, this one now. This one now. Okay. So my numerical is at the direction of alternating current gets changed in one cycle. So if we are having this one cycle, this is one cycle. Look, one positive, one negative, 2 times. So answer is 2 times. Answer is 2 times, right? Now look, if my frequency, second numerical, if the frequency is 50, 50 means 50 cycle. 1 cycle is 2. So 50 into 2, it will be 100. So 100 times. My answer is 100 times. Easy now? Easy? My answer will be 100, 100, 100 times. Done? Easy, super easy, no? Easy, na beta? Is it super easy? Topic that I'm just teaching you right now, no? So there are lot of things behind it, okay? Next numerical now. Okay, this one now. And I hope that you can do this numerical in a correct way. Okay, look now. So match the following column 1, column 2. We are, look, if we are talking about R means no lead or lag. If we are talking about C, in C, what happens? I leads. In inductor, I lags. Okay. We are in a resistor parallel to I, right? No lead or lag. VC means leads. Pi by 2, no. VC, if current leads, it lags. No? VC means pi by 2 behind of this. No? VL means P. So AQ, so this could be answer AQ. BR, CP. Yes, option number second. Option number second is correct now. Second is correct. Now next numerical. This one now. So look now, what is given to us? A very high frequency. If you know that last time, no, that means starting of the class, I told you what will happen at high frequency. The effective impedance. Impedance means resistance. Impedance means resistance. Look, high frequency. So there is no effect on resistance. Okay. Now what is given to us, sir? Here you are having a capacitor. So what will happen a capacitor? So what is XC capacitor? Is it 1 by omega times C? So XC equals to 1 divided by 2 pi F times C. If F increases, XC decreases. So we are having what? A connected role only. Okay, look now. So what is XL? XL is 2 pi F times L. It increases. So we are having what? Open circuit. Done? Look, this is closed, open, closed, right? So we are having a structure like this. One ohm. Here it is open now. 3 ohm, 2 ohm. So if current will flow, the current will flow in this manner. So total resistance is 1 and 2, that is 3 ohm. So 3 ohm is total 3 ohm. Easy? I told you now, before that, I just give you a very brief introduction. What can be the possibilities if we increase the frequency of my AC supply? Okay. Next numerical. This one now. Okay. So what we are having now? A resistance of 220 ohm. So we are having a resistance of 20 ohm connected to a source of AC, and AC 100 volt is given, 50 hertz is given. If nothing is given to us, so we have to consider it as a what? RMS? Yes, sir, RMS. So it is only about the resistance, so we don't need to talk about anything, right? So what is VRMS now? Sir, I guess VRM is equals to 100 volt, 110 volt. What is frequency? Frequency is 50 hertz. RMS current. So VRMS equals to IRMS into R. VRMS is 110. I is we don't know, and R is 20. So I came out to be 110 divided by 20. So it is 11 by 2, which will be 5.5 ampere. The answer for first one is 5.5 ampere. The maximum instantaneous current in the resistor. Maximum current. What will be the maximum current? Done. Look now. I equals to I naught sine omega t only. If we need this time to be maximum, so this to be maximum is 1 only, right? So I is equals to I naught. I equals to I naught. Okay, so we got it now. So I equals to I naught. I naught is 5.5 ampere. Okay, but no, it is not correct. Do you know why? Do you know why? The reason behind is IRMS equals to I naught by root 2, and it came out to be 5.5 divided by no. So 1 second, beta. This one is correct. I by root 2. So therefore, I naught is equals to IRMS. RMS is 5.5 root 2. This is my answer. It is 5.5 root 2. Third one, the time taken by current to change from its maximum value to the RMS value. So if this is my phasor, it is already here maximum, right? So now I want to go to the what? I need to go to the RMS. Look, here is 0, then it is 1 by 2, 1 by root 2, root 3 by 2. This is my RMS, right? So this is 90, then this one would be 0, 30, 45. So 90 plus 45, it is 90 plus 45, 9, 135. So it is 135 degree. So look now, already you are 90, so you have to 45 more. So 360 degree goes to T, 1 degree goes to T divided by 360. 45 degree means T by 360 multiplied by 45. Okay, 45 once 45, it is 90, 8. So I guess it is 8. So my answer came out to be T divided by 8. And T is 1 by F. So 1 by F whole divided by 8. It is 1 divided by 50, 50 into 8. 5 8 is 40, so 100, 400 second. This is my required answer. Easy or super easy? Better easy or super easy? Huh? Easy or super easy? Tell me right now, na? Easy, super easy. Next numerical. Next one is a very good one because you will get a how to do what? Superposition of two things, right? Next numerical on the screen now. So it is given my I is 3a sin omega t, I2 is 4a cos omega t. And I had to give I3. Now you can see here KCL. KCL means I1 plus I2 equals to I3. So I need to get I3, so I have to add I1, I2. What is I1? I1 is 3a sin omega t plus I2. I2 is 4a cos omega t. That will be I3. But look here, we are not dealing with vectors or scalars. We are having phasors. So if you want to add phasor, so add a phasor like a phasor only, right? Okay. So now if you want to add it like a phasor, so we know one thing, right? This is my sine, this is my cos. Okay. So you can see now 3a is sine. Okay. So 3 is sine. So here we are having sine. It is 3 sine. 4 is cos. So now add these both two. This is my resultant. 3, 4, it will be 5. So my result came out to be 5 only. My resultant came out to be 5 only. Okay, so look now, this could be my resultant. The resultant now 5 is 5 only, right? Now look now, 3 5. So this is my angle theta. Okay, theta now angle. So what is tan theta now? Is it 4 by 3? What is 4 by 3 now? Is it 53 degree? Yes, sir. So 53. No, incorrect, incorrect. My answer is first one is correct now. Okay. So take your 1 minute time to understand how I delivered this topic. Now we will start one of the most important topic from the AC, that means LCR series circuit. What we are going to deal now? I will write here LCR series circuit. LCR. So what we are having? We are having LCR. So I can have a resistor, then an inductor, then a capacitor. Both, all the three are connected like in a series. My input V equals to V naught sine omega t. Okay, so here my current I is flowing. So this is my VR, VL, VC. For a time being, it is positive, negative. It is positive, so it will be positive, negative, positive, negative, positive, negative. For a time being only. So how to write VR now? VR. Any idea about VR now? Yes, sir. VR will be VR naught. It is peak value sine omega t. If my current, let us have my current is I equals to I naught sine omega t plus phi. Let suppose, so it will be omega t plus phi. In a resistor, no phase difference, I will write 0 degree. What is VL? VL will means it is VL naught sine omega t plus 5. So what happens in VL? Current lags, but my potential leads by how many degree? Pi by 2 degrees. Okay, what is VC? It will be VC naught sine omega t plus 5 minus pi by 2. Pi by 2, right? So I can write V equals to IR. It is I into R. V equals to IR. It is I into R. V equals to IR. It is I into R. Done. Now let us apply KVL. Let us use KVL. Okay. I will write minus IR minus L di by dt minus Q by C plus V naught sine omega t equals to 0. Or I will write it as a minus VR minus VL minus VC plus V equals to 0. That means my V net equals to VR plus VL plus VC plus VC. Done. Just make a graph, all these things in your mind. Nah? Why? Because now I will deal with the phasors. Okay. How, sir? Look now. Look now. Look now. Look now. Look. Let us take as reference line now. A reference one. If this line is my reference line, right? If this one is my reference line, which is sine theta, sine line. But we assume I equals to I naught sine omega t plus 5. We assume this one. So my current, this equation will be my equation of current, that is I naught. if we talk about now my R, there is no lagging. There is no lagging in my R. So my R will be in this way. Now, if we are talking about my capacitor, so in capacitor it will leads by 90 degree. Or if we talk about the inductor, so in my inductor my potential leads VL naught by 90 degree. If we talk about now capacitor, what will happen in capacitor? Capacitor will be like this thing now. VC naught. It lags by 90 degree, right? Okay. This is my a phasor diagram of it. This is my a phasor diagram, and this angle is phi. Phasor diagram. Now, if this is my box, here force F1 is acting, here force F2 is acting. What is F net? F net means big F2 minus, if F2 is big now, so I will write F2 F1, so I will write F2 minus F1. So it is my net effect. This is my net effect. Done. Look now, if first case, if VC naught is more than VL naught, so it is difference will lie. Here. This is my difference of it. So what is the difference of it now? So this line represents, it is VC naught minus VL naught. Now you can see here, this is my VR, this is my VC naught. So I guess it is resultant. Will be in this way now. It is resultant. This is my resultant now. It will be now V naught. Resultant is V naught. Okay, now how to make it now? So we know that R, resultant of two vectors is A square plus B square if the angle is 90 degree. Look, angle is 90 degree, right? So what is A? A means it is VR naught square. B is how much? It is VC naught minus VL naught square root equals to, it is V naught. This thing you need to remember. A very crucial one, you need to remember this equation. I will write this equation once again. Now. Look now, I will write this equation once again. So my V naught is equals to VR naught square plus VC naught minus VL naught square. Then we are having a root. What is V? V equals to IR. It is IR. R means Z is impedance. Impedance simply indicates the net opposition created by the more than one component. Under root V equals to IR. I can write IR square. I naught XC minus I naught XL whole square. So I guess I can cut now. Look now. I can get something. So what? Look, I naught cancel out. So my net equation came out to be the impedance of circuit R square plus XC minus XL whole square to root. If we want to find the tan phi, the phase difference, right? So is it equals to P by B? What was P? It is VC naught minus VL naught divided by VR naught. Or I will write it as a I naught XC minus I naught XL whole divided by I naught. Sorry, it is I naught. 1 second. Is it I naught R? I naught and I cancel out. So my tan phi came out to be, it is XC minus XL whole divided by R. I know these things are very crucial to get remember, right? So for all these things, we are having a impedance triangle. Just remember this triangle only. Okay, we are having a triangle known as impedance triangle. Just remember this triangle only. How, sir? Look, this side is XC minus XL. This side is Z. this one is R, and this one is phi. Now, this thing is hypotenuse, perpendicular, base. So you will get this thing also, you will get this thing also by only remembering this triangle only. By only remembering this triangle. Easy, no? Easy or super easy? Easy or super easy? I guess very easy enough to get remember. Now, we were talking about a circuit in which a resistance was present, a circuit in which a resistance and an inductor and a capacitor, combinedly all these three were present. Okay. Now we will talk about two things. What's it? RL circuit, then RC circuit. In RL circuit, what is Z now? It will be only R square plus L. What is L? L is XL square root. In RC, it will be Z. Z will be R square plus XC square. Or R. What is R? Or I can write equals to V naught equals to, is it V R naught square plus V L naught square root. V naught equals to V R naught square plus V C naught square root. What is tan phi here? Tan phi, is it XL by R? Here tan phi equals to XC by R. I guess these things are very easy to get remember right now, right? Very easy now. You have to remember only, you need to remember only LCR circuit. Then after LCR circuit, we have these things. So in LCR circuit, now LCR circuit is not completed yet. Why? Because we only discussed one case in which my VC naught is more than VL naught. Okay, potential across the capacitor is more than potential across the inductor. Today there will be a when capacitor potential equals to the inductor capacitor. That is a resonance case. Okay. I guess and I hope that, look now, today is Wednesday. Okay. It is Wednesday. Tomorrow is Thursday. Then we are having Friday. So I will try to complete the whole chapter on Friday. So we will complete the whole chapter on Friday. From Saturday or from Monday we will start EM waves. Okay. Easy. I hope that we discussed a couple of great things in this today's class. If you have any doubts or if you want to ask me anything, you are most welcome. You can go to my Telegram channel, right? There you will find my personal Telegram user ID. Then you can just ping me a message there only. Okay. So for today, I guess we discussed a lot of things. So beta ji, easy, no? Any doubts from your end? Thank you, beta. Thank you. Bye. Good night. Good night. Thank you, beta. Good night. Bye.